whole journey where we are moving into MLOps. Before we embark on this journey, just a bit of information about me. Oh, that's a big image. So I'm an ML engineer at Swiss Post. I joined the company at 2018, and my background is actually computer science with some machine learning and advanced information processing. And at that company, or at the Swiss Post, I first actually joined in the marketing department, in the data analytics team, to provide analytical marketing campaigning leads based on analytics. And now I'm in the centralized digital data science team. My specialties are actually computer vision, NLP, and putting actually machine learning models into production. Before we move on, just a quick word about my employee. It's not actually an advertisement slide per se, but I just wanted to show you why I actually joined the team in the first place and what is actually happening in the Post. So we were crowned the best postal service multiple times. Actually, also currently we are, I believe. And not a lot of people know that, but we have some small innovation or big innovations happening in our company itself. So we have some drones actually which deliver parcels for hospitals, medical parcels, quickly with drones instead of roads, which would take too long for certain cases. And also because we have a very, very reliable public service, we have to deliver parcels in very remote regions, which is sometimes actually not feasible at all because they are that far away from roads. So what we did there is basically an IoT solution to provide these people with the ordering pen that they can press on, which then will trigger a postman or woman to go there and get the parcels or deliver the parcels. So this is just a quick word, and then we can move on to the topic, actually, to our journey. But first, actually, why do we want to use AI? I know it's a cool word or it's a cool thing to use AI now. Everyone does it. But we have actually some kind of incentive to do it. So first of all, from our physical world or from our physical services, we have a lot of trust from our customers. We are very, very semi-government function and very embedded in the Swiss culture. So we have this physical trust, and we want to move our customers to a digital journey. And we want actually to use that physical trust in the digital world to offer them new solutions which have not been used before. And also, yeah, some of you have actually said it before, but why we want to use AI is actually the huge amount of data we have at the Swiss Post. We are a big logistics company, so we have a lot of data for logistics. And the thing is, so this is an image of Black Friday. So once you enter the data world, data scientists are excited. They want to use the data, they want to make models. But as the talk before said, we have to wait for it a bit. That should be represented in that image. You have to queue in line. You have to wait for legal to green flag you. You have to wait for the data engineers to prepare the data for you. So there's a bit of waiting time to be able to use that data. But that's actually the essential thing that why we want to do it, or what's the perspective of data scientists in our company. So then also there is the view for the products instead of the data scientists. So because we are in the logistics department, there are certain products in the future that will use AI. So I talked about drones already, but also the whole planning, because the sheer amount of parcels will be very high in the future. We've seen that already now. So we need robust AI to be able to predict certain routes or predict the amount of workers you need to set up for delivery and stuff like that. You need to optimize the routes. You need maybe to use self-driving trucks, drones, or we'll have a lot of complaints in the future. You need to handle them. So we think, and also a lot of experts think, that by 2025, AI in logistics will take over a lot of our products, and we want to be ready for that, and also therefore increase efficiency in our processes. So without AI, basically, you cannot think of using any of these things. So now we established why we want to use AI. We need to have a clear plan how to use AI, because you cannot just use AI in a random way and be happy about it. So you need to have a plan and how you want to move to that destination, basically. So that's where a strategy comes into play. So there are actually 3 aspects of it that are important for us. So first, I already told you, we have a lot of trust from in a physical world from customers, and we want to transfer that in the digital world. But we need to make sure that we don't misuse that trust, because once you move and use AI, you can have potentially you can use it in a bad way, so to speak. So if you, I don't know, profile your customers, maybe tell them, okay, you are a fraudulent customer, and if you're not, you will move away from us, and we will misuse that trust, which we don't want. So we need that strategy, how to deal with it, with the legal team also. Secondly, we want to generate value. That's actually the reason we want to use AI. It's just not for fun. It's also for generating something out of it. So we need to have a plan on how to use that value, or how to generate value from AI. And the third thing that is also important is we have to align ourselves with the strategy of our corporate or digital departments. So we have to align ourselves how we move forward in these directions, also with IoT, which is closely embedded with us, AI or data scientists, and also this data strategy. So now, what actually are the problems you're trying to solve? So I think everyone here knows this problem or is facing it currently. So here you see the distribution of our cases. So you can see the vast majority, 93% of our cases are experimental still, and only 7% are productive. So why is it actually a problem? So the problem here is we don't just want to do proof of concept. We want to generate value, we want to generate products, and if you just experiment, you don't do that. So we want to be able to move from this diagram to a diagram with a much higher share of the pie, which is in production. So the reason I'm showing you this, because later I will tell you the reasons why this is actually the case and how we will solve it, or how we plan to solve it. So before I move on, just a quick view of our strategy, or of our measures we are taking in 3 years' time. So these are the components of our strategy. So you see technology, data management, people capacities, change, setup, and partnerships. So just a quick word about some of them. So technology and tooling is very, very important. So you need to make sure you have the right platforms, AWS, Azure, and stuff like that, Kubernetes, and whatever you want to use. You need to have a solid data management system in place, and also you need capacities of people and capabilities of people to handle that workload and to deliver your solutions. So you need to invest in people. You need also, the company needs to be aware of data culture, which was alluded before. So you need a kind of culture program, which we have. We are actually crowning digital champions, which are representative of us in our different departments. We need to change. We need to have an organizational setup which actually gives you the solutions to be able to deliver AI solutions, basically. So the reason for the problem mentioned before, why we have so many experimental cases, is actually in this picture. So the way we are set up is we have the business who owns the idea and the data, and they might have a problem which can be solved with data. And we are set up in a way that the business has actually specific data centers very close to the business itself. So the reason why, because they have domain knowledge, and then they can do greater analysis of the problem than centralized teams. And what they will do is actually a first modeling of the problem, coming up with doing some analysis, coming up with some first models, first drafts. And this might take 5 to 10 days. It's just a POC. And then the next step would actually be to deploy it to production in the best case, which doesn't happen often enough. And that's where I or our team comes into play, and we are the centralized analytics team. So we take that model, deploy it, or improve and deploy it. And here actually lies the problem. So the business goes to the center, and the center tells them, okay, we can do it in 5 days or 10 days, whatever. And they're happy with that. And as soon as they want to move forward, the problem is then we have to estimate how you deploy it. And that takes maybe 20 days because you have to think about more stuff than just a POC, basically. And the business then says, no, I'm not doing it. It's too much investment for us. We are getting cold feet, basically. And this is actually the heart of the problem. So you can see it exemplary here. I will actually talk more about this solution or product. So just a quick word about the product here. So we are a logistics company, and we actually we deliver letters. So if you are sending a letter, you need a stamp. So normally you can buy a stamp from the post office, have it on the letter and get it sent. But what you can do with us is actually you can send the SMS to a number. You get the code, which is the top right corner. And that code is actually a stamp. So this is like a physical stamp. You can then send the letter in a letterbox. You don't need to go to an office. So what you need to do, or what the problem here is to detect what is written on that code. So what happens here, you need to make some pre-processing. So the first is the image, and then you need to extract where the stamp is, mostly top right, but sometimes somewhere else. And the next step is to have a machine learning or a deep learning model, which we did, to detect what is actually written on that stamp so that you can make sure that it's a valid stamp, basically. So, okay, that's a POC. You can do maybe not in 5, maybe in 10 days. You can say we have a deep learning model, precision is 90%. Cool. But you're not done. So the next step is actually what you need to do if you want to deploy it. So you need to think about drift, about continuous deployment and integration, how you have the best model always in the pipeline, how you integrate that back into the system, how you communicate with the system itself. So these all are reasons why it takes more than 5 days to have a productive model. So what we offer now is for the decentralized competence centers, we offer a service where we are there from the beginning, consulting them what they need to think of if they want to deploy a model and what the cost will be so they are not surprised in the end and just don't do it. But that's one aspect of it, actually. The next aspect is to be able to do it in the end. So how do you make sure you can do it? Because sometimes your company is not ready for that. You don't have the people for it. So from the strategy before, these are actually the points that are important to be able to actually deliver the solutions. So you can see a big point is capabilities and capacity. So you need to have the people, engineers, data engineers, software engineers, architects. You need to have them in your organization. You need to have a solid technology and tooling foundation. And you need to have a certain organizational setup so the people that actually will deliver the solutions are very close to each other so that there's not a long way of communication all the time. So alluding to the last point, the organizational setup, this is how we are set up from, I think, since 4 weeks, actually. So you can see we have actually a cluster, we say, a digital enabling cluster. And then on the left corner, you can see we have a data insights team. So what we did, we grouped everyone together that has to do with delivering machine learning solutions or data solutions. So we have a big data team, a business intelligence team, advanced analytics team, and then you have some experts, ethical experts, because we need them. Because if you do something wrong, it will be in the news next day. So we need ethical experts, IoT experts, because we group them together, and other experts. So this is actually the setup we have now. So we have them together, and then we need to actually work on it. So what is actually the goal or the vision we want to achieve? It is this picture. So maybe some of you have seen it already. It is the standard MLOps picture. So we're coming to the title of the talk. So we identified 3 phases of MLOps. So you have a design phase. So basically the design phase is actually more requirements engineering. So you need to define the problem you want to solve. You want you need to define the data you want to use, because the data is also decentral in our case. You need to check if it's available, and then also maybe prioritize which cases you want to do. So this is more of a business analyst role in that sense. And then actually comes the part of developing the model, which is the second circle. So there you need data engineers which actually ingest the data or write some ETL pipelines. You need actually to come up with the model, so you need data scientists or machine learning engineers. And then you need to test and validate that, where you actually might also need the business depending on their problem. And then when you're happy with the model, you move into operations. So that's MLOps, actually derived from DevOps, just for machine learning. So you need to deploy the model. You need to have solid pipelines so you can automate actually, or don't need to do it manually every time you have a new generated model. And then also need monitoring, so you can actually react to model drift or changes in the data. So the basic goal is actually to just be able to adjust to new changes, to automatically deploy the model, because otherwise it takes too much time, and also react to model drift. So this is actually the goal, and what we are doing now, or where we are now, is actually we created a group. This is actually just how we work. So this is MLOps working group currently. So what we did here, we grouped everyone together that is working on machine learning. So data engineers, architects, data scientists or ML engineers, software architects, big data engineers. So here we can see some principles that we are trying to apply. So we are trying to be cloud first, we want to versionize the models, validate constantly. Also consider SLAs, which is a very interesting topic now. Who is maintaining the models once it's deployed? So it's also a work in progress. So these are the things we are working on actually right now. And you can already see some of that in some use cases. So we are back to that one. So this is the picture from before. So you have a model, you want to train, and then we identified 2 cycles, basically. So the first is a training cycle. So this is our normal machine learning cycle. So when you have some data source, in our case, the images, labeled ideally. In that case, it was not labeled in the beginning, but yeah, that's a challenge in itself. And then you need to do some exploratory analysis. Where is the stamp? Normally, is it top right? What kind of images are there? Are they corrupt? Are they not of high quality? And stuff like that. And then actually comes the phase of training the model itself. In our case, it was a ResNet model. I will not allude to that at all. There's a deep learning summit if you want to have more deep learning stuff. And then once you're happy with that model, you actually deploy it to a registry. And then you provision the model and use it. And once a new data comes in, the cycle starts again. So you do that scheduled, reacting to some changes, however you want. And the end product actually looks like this. So it's very abstract, but basically you have a provisioned model on the right, which is deployed on a AWS cloud in a container system. And basically a Java application which handles a business logic, just calls it, and wherever there is a new image, and then gets a response back and writes this in a topic, or does with it what it wants, actually. So we decoupled, basically, this is a predict cycle, so it's decoupled from the train cycle. We just use the latest model, and we decoupled the model in a microservice, so to speak. So this is one case. The next case is actually a bit more sophisticated. So here you can see the view of our customer agent it's a customer agent case. So basically, mails come in to our customer center, and they need to identify or create tickets out of these mails. So they need to answer certain questions about the mail, as like what kind of process the mail is about, what kind of product is it about, what language is it, because not everyone in our customer center speaks all the languages, and we are a Swiss team, so we have 4 languages. Which team should actually take care of it, other things like what kind of entities are there. So these are like basically the questions you need to answer. So then the problem of the machine learning thing is actually you have a mail, you want to have certain skills, we call them, so the labels like process, product, issue, language, and service line, and some entities like barcode, shipment ID, email, and other stuff that can be used to display it automatically or can be used in to automate the whole flow if you want. And then actually then comes a training cycle, which is basically you extract certain features out of the mail, the addresses, the body, enrichment of the body with the entities you just generated, information about headers and so on. You create some models, in our case logistic regression, and then use that model to predict for new mails. And then here, the specialty of this one is actually that the agents need to interact with it. So we have an interface where the agent should be able to retrain and should be able to add new categories. So because we can have new things like Corona, you have new categories that you didn't have before, so you need to be able to add them, or the agents need to be able to add them actually, and retrain it. And before I show you the front end and how the workflow is, just a quick look how the end result looks like. So you have basically the mail, and then you have the skills, which they can see in their CRM actually. So they see the language, they see the product, the process, and so on. They see the entities directly here. And before it was just this rule. So you can see it's much more information than before. Just visible, not even needing to open the mail, so you can see everything you need actually just here and can act upon it. And then actually there is the part of interacting with that whole thing. So here you can see you're in the training phase, so you can add new data, which is done in the bottom left corner, so number 1. You can add new labels to it, so you can label data automatically here. This is just one mail. You can do a bulk upload for 300 mails, which you can label manually here. You can also add new labels that didn't exist before and then relabel new mails that, with the new labels. And then actually here, the important part is how you actually deploy the model and set it live. So the thing is, the agent here needs to retrain themselves. So they can, in this interface, they can start a retraining. If they have new data submitted, you can see this is the whole interface. You can see which model is live. You can see all the trainings that have been done before. And then the agent actually can look into the model and see the confusion matrix, other matrices. And if they're happy with it, they can just deploy that into production, basically. So here they have all the power is with the agents. There's no scheduling, automated deployment to production in that case, because it's a very special case. But the deploying to integration is done automatically, just like before. So these are like the two cases. And now, how do we combine these two principles? So basically, we created this architecture. It's a bit big, but actually you can see the 3 phases. So left is the explore phase, so you do your normal exploration in, I don't know, SageMaker or whatever your notebook you're using. You access different data sources, maybe ad hoc, maybe in the cloud. And once you're happy with that, you're actually in the build and train phase, which is on the right top. So you can train the model. Once you're happy with that, with the logging, with the metrics, and so on, you deploy it. Build a container, deploy it. And right, you can see the tool chain. So we are using Jenkins, Bitbucket, and standard tool chains. And once the model is versionized and registered, it goes in this MLM model container thing. And there you need to have standards, basically how you do that. So you need to have a validation, standard validation logic, a logging logic, A/B testing, also important, and some kind of way to display the metrics in a standardized way. So then the thing on the bottom actually interacts with the real world. So you can basically have a business application that accesses it, or maybe have a scheduled run every day, depending on how you want to do it. So this is actually a very general view of how we do it, but also very standardized. I'm almost finished. So on the bottom view, I just have a way with REST APIs to interact with it. So what's the conclusion of all of this, actually? So before I conclude, just a few topics that we are working on currently also. So service level agreements. So we deploy the model, who is responsible for it? We're actually just working there because it's not quite clear who should be responsible if something goes wrong, and how we will deal with in time critical responsiveness. So that's some problems we are trying to solve. And then this thing here, this is a bit of a template, so we're standardizing everything. So we're standardizing, making blueprints. So we have some cases like a stream case and the batch case. So we have blueprints of them. We want to have best practices on how to scale that. And also we are evaluating if you're using entirely AWS or trying to do it on our own, because you can use AWS for everything, but then you're locked in AWS. So you have their model registries there, the SageMaker endpoints or the endpoints are there, other stuff is there. So it's a bit of a trade-off how you deal with that. So now it's my conclusion. What we have done is actually we have made a service for data scientists to help data scientists move from experimentation to production. And we have addressed the cold feet syndrome so that they don't want to do it. And also we have changed a bit of the structure we work in so that we can do it. And we are in work in progress in how to do it in the future. What is the best way, how you standardize that. So yeah, we are in the beginning of our journey, as you can see. So I hope to exchange some ideas with you guys where you are in your journey, and maybe have a discussion how you could best approach that problem. So yeah, now it's time for questions.
Thank you.